record this. Okay, so on this problem, it's one of those problems that can be either you don't have a clue what's going on, or it's really easy once you get it. The problem is that it's so simple in the fact that there's no x's and stuff that sometimes it confuses you. So we're looking at this right here. You have y is greater than or equal to 4. So again, I always look at the inequality if it were an equation. Y equals 4. So there's a couple ways to do this. One way you could think about it is in slope-intercept form, which is y equals mx plus b, that if I turn this into slope-intercept form, it would be y equals 0x, because there's 0 x's, plus 4. That makes sense? So it could just be in slope-intercept form. Okay, and then where does it cross the y-axis? 4. Now since it has a slope of 0, what does that tell you with the line?
It's a vertical line.
It's not vertical.
It's going to be
Horizontal line, yeah, it's flat.
I know the difference.
So you draw this, and there's your line. Now that's the line y equals 4. Now, I want to double check here. I'm going to look back. Since this is underlined, is that a solid or dotted line? Solid. So I'm going to leave that solid. Okay. And now I still substitute in a 0, 0. Well, there's no x's. So all I need to do is substitute a 0 in for a y. Is 0 greater than 4?
No.
No. So 0, 0, don't shade that. We want to shade above it. So we can do that. And that is our thing. That is our graph. Okay, it is pretty easy. The tough thing was, again, this 0x part. One thing that I always memorize is that if I have a y equals any number, so if I have y equals any number, I'm going to have a line at that number that is horizontal. If I have x equals any number, it will be a vertical line. Okay? Let's move on to the next one. Okay, so now we have actually a system of inequalities to graph. So I'm going to put just right up here, system. A system just means you have multiple ones to graph here. So we have 2, and the goal here is we're going to find out, because since they're both inequalities, they're both going to have some shading, and the goal is to see where the shading overlaps. Okay? So if I graph this first equation, I'm going to do different colors here. I'm going to do this one in red here. So where would I start on that top equation? 2. So you're going to start at plus 2. Okay. And then we look at, that's our y-intercept. Where's the slope of the line? What is the slope of this line? 1/2. The slope is 1/2. So we're gonna from this 2, we're gonna go up 1 over 2. So again, from that point, we start at this point, and then we go up 1 over 2 because it's 1 over 2. Okay. Now, is this line dotted or solid? Solid. So I'm just going to go ahead and make our line through here. Now, if I don't have a ruler, if I have a ruler, I use that. If I don't, a lot of times I'll just use that same ratio of 1 and 2 and draw a lot of dots. So that way I get a little bit better picture without a ruler. Okay, now the second one, I'll change colors here and I'll go blue. So for this one, where's the starting point? -3. So our -3 is our starting point on our y-axis. So these are y-intercept or slope-intercept form. So that's why we always start on the y. Okay? So that's -3. And what's the slope on this? The slope is -2. So -2 is the same as -2 over what? 1. So we're going to go down 2 and to the right 1. And that's going to be our slope. So again, I can just do this. Use the same dots. Is this one going to be solid or dotted?
Dotted.
Dotted because it's not equal to. Because it's not underlined. not equal to. It's going to be dotted, so I'm going to try to do some dots here. Dash line, however you want to say it. That means that those points on there are not equal to, but it gets pretty close to that. So there's our two graphs. Now I'm going to go back and do my shading. You could have shaded after the first one, so I'm going to switch back to red here. Okay.
I want the other way. I want -1. Okay.
So now I'm going back to the red one here. I'm going back to the red one here, and I'm going to shade based on my point 0, 0. So the question here is 0, 0 in the shading? So if I substitute that in there, I get 0 is less than or equal to 2, because 1/2 times 0 is 0. Is 0 less than or equal to 2? Yes, that's true. So that means, since it's true, we shade this 0, 0. So I'm going to go ahead and shade. Now when I shade on my graph paper, what I usually do, since I don't have usually colors, I'll just draw lines that go away from the line. Yes, Eli.
So don't just have a shade where both of them, like...
Right, I shade each one individually. So, and you can do both. The thing is, some people forget where they shaded, where they overlap. So here's what I do, and again, you don't have to do it this way.
Yeah, he just told us to shade like where the...
I do this on that one, and then I go back to the second one, substitute my 0, 0 in. 0 is less than -3. Is that true or false? False. 0 is not less than. So that means on this blue one, I'm not going to shade 0, 0, so I have to go away from it. So I shade away from it. And then I will shade on my paper, darken in where they overlap. So that means you don't, if you can do it without it, that's fine.
Or he just kind of like draw arrows where they did it.
Right.
Shading it.
Yeah, if you can keep track of that, that's great. You can do it that way. I look at the overlap here. Now, one of the reasons I do that is because now, if anybody asks me about a question, for instance, if somebody says, is 0, 4, here's 0, 4, is 0, 4 part of any solution? It's not shaded at all, so it would be a no. Okay? And then the second one would be maybe, is 3, 2 part of the solution? Oh, that's only the solution for the first one and not the second one. Is -4, 2 part of the solution? That's only a solution for this one and not for that one. And then anything in this area is a solution for both. -3, -3, -2, that's a solution for both. So then you can actually answer a lot of questions about solutions then. Okay, questions there?